to another exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're coming back at you with more VMware. That's right, VMware Certified Professional version 6, and we've been looking at managing availability. Joining me in the studios today again is none other than Mr. Don Pizzette. Don, how you doing, sir?
I'm doing just well, Wes. We're ready to continue our journey into keeping our stuff online even when it fails. In our last couple of episodes, we've had a chance to see vSphere HA, high availability. But in this episode, we're going to switch gears a little bit, and we're going to take a look at Fault Tolerance, or FT, and we're going to look at DRS, the Distributed Resource Scheduler. I know I've mentioned DRS several times in the previous episodes. You've never actually used it. Now is the time. All right. I do, however, want to start with Fault Tolerance first, mostly because it's easy and it's quick, but because it is on the exam, it's something we need to know about, and it does address something that we saw in our last episode. So if you watched our high availability episodes, when we were setting up vSphere HA, there was an option in there for how we could detect whether our virtual machines were healthy or not. It asked us if we wanted to turn on Virtual Machine Component Protection, VMCP, and that let the cluster look into the VMs and see if they lost their network connectivity or if they lost their storage connectivity, that they knew there was a problem. Even though the virtual machine might be online and look healthy, we might even be getting heartbeats from it through the VMware tools, but it's not actually healthy. VMCP lets us see that. The reason I bring that up now is that fault tolerance, what I'm about to talk about, is not compatible with VMCP. So if I turn on the FT functions, it disables VMCP automatically. It does it for you, right? So if you forget and you turn them both on, FT wins, right? Remember that, because that's kind of a good exam question right there. Which one takes precedence? It's FT. All right, so what is FT? What is fault tolerance, and why is that important to us? Well, what fault tolerance does is something a little bit different than HA. With HA, I could have a virtual machine up and running on one host. And if it were to fail, another host that's connected to the same storage could grab the control of those hard drives and boot that virtual machine and have it up and running, right? So I have two hosts that see the same storage, and they're both able to boot the same VM, only one at a time. That's how HA works. Fault tolerance does it a little different. Fault tolerance doesn't actually require shared storage. With fault tolerance, I can have a VM running in one data store on one host, and I could fail it over to a host in a completely different location, in a completely different data center. Maybe I have a disaster recovery location somewhere else in another geographic location, and I can fail over to that. Well, let's say that I've got my main data center in Orlando, Florida, and I've got a backup data center in New York, and I want to fail over from Florida to New York, right? So I want to set that kind of thing up. Well, I can't really get a host in New York and run fiber and plug into a SAN down in Orlando. And I wouldn't want to even if I could, because if the Orlando data center fails, I probably lose that SAN. So I don't just need to be able to flip the VM from host to host, I need to be able to flip to an entirely new SAN. And vSphere HA doesn't let us do that. It doesn't have that functionality. You need your host to see the same storage. The storage needs to be reliable for HA to work. With fault tolerance, what it does is it says, all right, you can have the VM down there in Orlando, and it can be running on a server, it can be on a SAN, everything's running and it's happy. And I'm going to clone that VM. I'm going to create a clone of the virtual machine and store it up in New York. And I'm going to keep it synchronized. As changes occur to the one in Orlando, I'm going to synchronize those changes up to New York. But the one in New York is just going to sit there idle. Okay? But it's on a different SAN, it's on a different host, it's in a different data center, completely separate environment. And if something happens to the Orlando data center, if that node goes down, we can just spin up the VM up in New York. I don't have to synchronize, the data's already up there, and we just boot it up and we go. That's what fault tolerance does. FT gives us a much more broad solution. Now, FT by itself has a little problem, and the problem is synchronization. How long does it take to synchronize changes from Orlando to New York? Even if I have a ton of bandwidth, it still takes time. If I've got a database that's getting rapid changes, I can lose a few seconds of data when we fail over to New York. Now, what's a few seconds of data to you? Well, to us, it's not much, right? To IT Pro TV, we film video, and our video gets recorded locally. The few seconds really wouldn't matter to us. It's not a big deal. But if you're a stock exchange, and you're processing millions of financial transactions per minute, a couple of seconds of data could be billions of dollars. I mean, that's a big deal. And so fault tolerance is not the perfect solution. But we know that vSphere HA is not the perfect solution either, because it really doesn't let us span multiple geographic areas without jumping through a lot of hoops. So what do? And the short answer is you combine them both. That you use fault tolerance and vSphere HA. You combine them both. So you're running HA inside of one data center and then using FT to clone off to another data center. All right. Now, there is a way to do multi-site HA. It's not on the exam, and it's actually really difficult to set up, but you can do it where you span that way, and it relies on your SAN replicating itself. So if you have like an EMC SAN, EMC has this Replistore functionality, and basically it lets one EMC SAN in one location replicate data to another EMC SAN in another location. It does fiber channel over Ethernet, and it syncs that data. It hurts your performance a little bit, but it makes sure that you have two SANs with the exact same data. So now I can have nodes in two different locations that are part of the same vSphere HA environment. So you certainly can do it, but it's really powered by the SAN more than it's powered by VMware, so that's why it's not on the exam. But fault tolerance, we can do that entirely within vSphere, right? So let's jump in and take a look at that. First thing, I need to enable the functionality. Fault tolerance is going to synchronize a VM, and it's going to synchronize it using a VM kernel adapter. So I've got to make sure I've got it set up for a VM kernel adapter. If I go in and take a look at one of my hosts, right? So I'm just going to drill down here to one of my hosts, and I'll go to Manage and Networking. And these are the same hosts that I used in the HA episode, so I'm already set up for vSphere HA, but I'm not set up for fault tolerance. I'm drilling into host 01, and I'm going to go into VM kernel adapters. And you may want to set up a dedicated adapter just for FT. That way it can synchronize and not impact the performance of your other adapters. Or you can piggyback it right on one of your existing ones. I've only got one adapter, so I'm going to piggyback it. But in production, I love to move it off to a separate adapter. Network adapters are cheap, so there's no reason not to add a bunch of them to your servers, and then you start to eliminate that congestion. All right, so I'm going to edit this kernel adapter, and when I go to do it, notice one of the functions right here, fault tolerance logging. Okay, I can turn on fault tolerance logging, and what it's talking about are transaction logs, the changes that occur. So when a VM gets modified, the changes are stored in a log, and the log is shipped over to the other server, and the logs are then played forward on the other server, so the same changes happen there. So I'm just enabling it on this adapter. That's going to let me use fault tolerance. If I don't have fault tolerance logging turned on any of my kernel adapters, then FT doesn't work. So that's kind of important. The next part is to turn it on, and we turn it on a per VM basis. So you go to each individual virtual machine that you want to replicate, and you turn it on there. So it's not like HA where it's done on the cluster. Here it's done on the individual VMs, because we might not want to replicate every single VM. Well, I've got a VM sitting right here, Web 01. And let's say that web server is really important to me. I want to replicate that to other locations. Okay, so if I want to do that, what I need to do is get into that machine's settings. I'm just going to right-click on it, and in the menu that comes up, you'll see fault tolerance right there. And we can turn on fault tolerance. Now, there's several options that you're going to see in here that are based on if it's on, right? If it's off, all these things are grayed out like mine are. But when we turn it on, you'll see what we can do. We can suspend fault tolerance, we can resume it, we can flip over to our secondary copy, we can test failover, and we can test restart the secondary. There's a lot of actions you can take on that backup copy that you've got, all right? And there's different reasons why we'd use some of these. I'm gonna go ahead and turn it on, and then I'll talk more about those in a second. Now when I go to turn it on, it's warning me that I've got a host fired up, but I'm going to have a little bit of a bandwidth problem. I've got insufficient bandwidth for vSphere fault tolerance logging. They really want you to have that dedicated adapter, right? Because think about your virtual machine. If my virtual machine is connected to a gigabit adapter, that means I could be receiving up to a gigabit of changes at any particular second. Well, if I'm replicating my changes, if I'm doing my fault tolerance logging on that same adapter, now I'm creating contention. How can I send a gigabit of changes somewhere when I'm receiving a gigabit of changes? I'm going to max out the adapter, right? Even if it's a full duplex gig adapter, I would be maxing it out. And so nothing else would be able to function on it. If I've got shared with more than one VM, now I'm really in trouble, right? So it's warning me about that. Now, it's still going to let me do it, but it is warning me. So it's saying, do I really want to do it? And in my case, I know I'm not making changes to the VM, so I'm not really worried about it. I'll go ahead and say yes. In real life land, you solve that problem by having more adapters. All right, now it's asking where I want to put it, right? I need to pick a data store where it's going to go. And so what you do is you pick a secondary copy for it. And notice we've got 3 different files: a configuration file, a tiebreaker file, and the hard disk itself. The configuration file, that's your VMX, right? The configuration of the virtual machine. That's got to be replicated so that we know to build the VM. And the hard drive, I've got an 8 gig hard drive. It's small, so that's obviously got to be replicated. A tiebreaker, what the heck is that? Well, remember when we configured the clustering in our earlier episodes that we had to have a quorum and we had a data store that served as that heart beating? Well, because I can replicate this to a data store in a completely different environment, it's going to tell me, hey, I need some kind of tiebreaker. I need some kind of heart beating. And it's got to go somewhere. And so the way it does as a file that's going to get replicated over to the secondary. Okay, so that's kind of what it's showing me here. Now, with each one, I've got to pick where they're going to get stored. And so over here in storage, I just have a browse option. And I can drop that down and browse the different data stores that I've got. Okay, and so I can pick other data stores. And these data stores might be right here in this geographic location, or they might be in a different data center or a different location. I can pick where I want it to go. So I believe that node currently exists in storage 01, so I'm going to go ahead and move it to storage 02. And I'll just do that for each one of them. I'm going to go down the line and browse and pick it. They don't all have to go to the same place, but typically that's what you want. You usually want them all to go to the same place. So I'm going to go ahead and pick that. Notice when I get to the actual hard drive, I got a few more options here because it's showing some of the other data stores. For the tiebreaker and the configuration, all the servers need to be able to see it, so it really needs to be a shared data store. But for the hard drive, because we're going to replicate that, we're going to clone it, it lets me pick even local data stores if I want. So if I know that I'm going to be replicating this over to host 02, I could stick it in host 02's local data store, and then it would go there. But I've got shared storage. That's what I'm going to use. All right, so I'll go ahead and choose that. And we've got it laid out. I did get a warning. Actually, what's my problem here? Hopefully it'll be a detailed error and I can find out what's going on. So it's telling me there are no hosts compatible with the current data store selection. So that's not good. I got host 01 is not valid, and that's because you can't have a fault tolerance pair between 2 VMs on the same host. You can't be fault tolerant on one host. So that makes sense. But host 02, oh, this is embarrassing. All right, so the fault tolerance configuration on the end of the ESX host 02 has an issue. Host cannot support vSphere fault tolerance. Check the host summary. All right, I've already got an idea what's going on here. So host 02 doesn't support fault tolerance. Why not? Right? Fault tolerance is in my license, the license that I have applied to these machines. So why isn't it supported? Well, let me show you how you can find out. If I cancel this and I go to host 02, I can jump over to the summary, which is what they're suggesting. And in the summary, if you go over to configuration, you can expand that out, and you can see what's supported and what isn't. And notice my fault tolerance here is showing as unsupported. And if I expand that out, mine's already configured, or expanded, I can see virtual NIC for vSphere fault tolerance logging not configured. Remember that thing that I covered right at the beginning of the episode where I said you gotta turn on fault tolerance logging? I turned it on for host 01. I kind of forgot to turn it on for host 02, so that's what my problem is. So I need to take host 02 here and just go into manage and go into networking and the kernel adapter. I need to edit that kernel adapter and add fault tolerance logging. If I don't have that, fault tolerance doesn't work. So good lesson there is that it has to be on the sending and on the receiving side. We got to have both of them set up with that fault tolerance logging. So now I should be able to go back and turn on fault tolerance for that VM and hopefully get some better results. Okay. So as I go through, I'm going to pick my storage again. I'm going to pick shared storage for my configuration file so that both systems will be able to see it. And I'll pick shared storage for my tiebreaker file. Those are small files, nothing too significant there. You could even use NFS for it if you wanted. You don't have to have a SAN. NFS actually works better over a geographical area, so a lot of times we'll pick those. But then for the hard drive is the more important one. And for that one, I don't want to pick shared storage in this case because maybe I'm at a remote location that doesn't have that SAN, so I can choose a local data store or any other type of data store for that matter, and I'll go ahead and choose it. All right, so now that I've got it chosen, well, I see that I've still got a warning down here, and now it's telling me vSphere fault tolerance requires the host to have a license that supports vMotion and a virtual NIC enabled for vMotion. So I need vMotion for doing a live failover, for doing the testing. In an actual failure, I don't necessarily need vMotion, but in a live one, I do. And I didn't turn on vMotion also, so this is like a comedy of errors here. I basically need to get those turned on the adapter. So I'm going to go in and edit that. Even though I don't necessarily intend on doing a live migration, it needs that turned on. So I'm just going to add vMotion traffic right in there. Okay. So I'll do that over on host 01 too, and that should be the last of the requirements that we've got. It's unfortunate that they didn't warn me about that ahead of time. We could have knocked it all out at once, but what are you going to do? All right. So now we'll go ahead and take Web 01 and we'll throw that into fault tolerance. And we'll pick our storage again, just like we did a moment ago. And this time, everything should be happy, shiny rainbows and unicorns. At least I hope. So all right, so once I get these picked, then we'll be able to advance. And you know what I'm doing here, I'm setting up fault tolerance between two nodes that are actually already in a cluster together. It doesn't really make sense to do this, right? In a production environment, you really want fault tolerance to be to a host that's outside of the cluster, that's in another location, right? It'll let me do it here, but in an ideal world, these would be remote. Now it's happy, right? My host 02 meets the compatibility checks, and I can move forward, and it's going to get it set up. All right. Now, what it's asking me here is I need to pick my secondary VM. Okay. Right now, I've got affinity for host 01. That's where I created the VM. I want host 02 to be the secondary. But you may have more than one person that you can pick from. So you choose who you want to be that secondary. And over here, you'll see if they have HA configured and what their state is. And so notice that we've got the running and connected, the master and slave model. So the second server here is basically sitting idle. Now, I do have a warning because I just have that one network adapter is what that warning is. All right, so I'm going to go ahead and hit next. And now we can finish that up. And what's going to happen is it's going to create a clone of Web 01. So there's one copy of Web 01 right now. It's going to create a clone over on host 02. So there'll be a second copy of the VHD. And the configuration file and the tiebreaker will be copied to their store also. And so those will all be available and ready for use. That's going to happen in the background, and that can take a little bit of time. On a local network like mine with just an 8 gig hard drive, it might happen pretty fast. If your server is a terabyte in size and you're replicating over geographic boundaries, this could take hours or even days. It can take a while. So we need to wait for that to synchronize to be up and going. But once it's done, we'll now have fault tolerance enabled for this VM. Web 01 is now being synchronized to the other side. And when you right-click on it and float over fault tolerance, you'll start to see some of the options that are out there, like resume and suspend fault tolerance, migrate to the secondary. I can flip over to the secondary if there's a failure happening, if I can't get to that VM for some reason, right? Now, migrating, that makes sense. We know when we do that, you're having a failure. Testing, that makes sense. We want to make sure it works. When would we use suspend and resume? Well, let's say you're about to do some big software update to your virtual machine, and you're worried that it might break something, right? You didn't have time to do full testing or whatever. You could suspend fault tolerance and upgrade the production machine, and the replica would not be upgraded. And so now if something really went wrong, I could kill the VM and fail over to the secondary, and it would be like rolling back the update. You can achieve the same thing with snapshots if you're set up to be able to handle snapshots, but if you're not, you can use fault tolerance to kind of cheat the system. That's one reason. Or maybe your bandwidth is getting killed by replication, and so you suspend it so that you can start it up at night again, knowing that your replica is no longer going to be quite up to date. So you have to be careful with that. But otherwise, it's on, it's running, and it's pretty straightforward. Fault tolerance is one of the easier things to get configured once you meet all the little requirements, right? So I did have to jump through a few hoops to get that thing in place. But now that it's going, we've got fault tolerance configured, and the VM should be up and happy. All right, now, fault tolerance is fine, but you might have noticed when I was configuring it that when I went into the host and I looked at my summary, did you see how they named fault tolerance? It was named fault tolerance legacy. Okay, the reason it's called fault tolerance legacy is because it's being replaced by vSphere replication. vSphere replication is a new service that lets you replicate pretty much anywhere, and it's a little bit easier to deal with on the requirement side. And so fault tolerance is still supported, it's still on the exam, but it is being phased out. All right, the next technology I want to talk about is the distributed resource scheduler. Everything that we've set up so far has really been manual. When we set up vSphere HA, the high availability, what we were doing there was setting it up so that a virtual machine could jump from one host to another if there was a problem, right? If one host failed, we could bring the VM up on another host. Or we could do it ourselves. If I wanted to do maintenance on a host, I could use vMotion and move the VMs off to other hosts and then do the maintenance, and it wouldn't affect anybody. So all of that is manual. But a lot of times we want these things to be automatic. Well, it is a little automatic. If there's a true failure, if a host actually goes offline, it will shuffle around your VMs for you. It'll take care of that. But what if it's not that the host is offline? What if it's just performance? What if I have one host that is maxed out on CPU? It's got 12 cores and they're all running at 100%. And I've got another host sitting right next to it, and it's got 12 cores and it's running at like 6%. Well, it'll let you do that. By default, the cluster doesn't do performance balancing. So that's where the distributed resource scheduler comes in. With DRS, it can look at your environment and it'll see that one host is running at 100% CPU and another host is running at 6%. And it'll grab a couple of VMs and move them over to the other host and balance it out. So now maybe both of them are running at 60%, right? So it balances them to create an even distribution on your hardware. The distributed resource scheduler is really cool. Not just because of that, right? Because it balances hardware and performance, which is great. But it can also do power savings. The power saving stuff is really neat. Let's say that you have 100 hosts and you've got 10 VMs on each host. So you've got 1,000 VMs. 1,000 VMs, 100 hosts. Those 100 hosts, that's 100 physical servers. That's going to consume a bit of power, right? So it's going to cost you a decent amount of money to keep that up and running. But maybe your business is an 8 to 5 business. You open up at 8 a.m., you close at 5 p.m., and overnight, what are your servers doing? Nothing. They're just sitting there. Maybe they're getting backed up, but for the most part, they're just sitting there, right? What DRS can do is it can monitor the workload. It can monitor how busy your VMs are. And during the middle of the day, from 8 a.m. to 5 p.m., maybe it's got all 100 hosts up and running, all 1,000 VMs, all just cranking full steam, right? But then when 5 o'clock rolls around, and then 6 o'clock rolls around, at 6 p.m., everybody's gone home, everything starts to idle, DRS can recognize that. And it can move the VMs to consolidate them down. And maybe those 1,000 VMs that needed 100 hosts can now run on 60 hosts. And it can take the other 40 hosts that it doesn't need, move the VMs off of them, and put them into sleep mode. It can put them to sleep overnight. And then in the morning, when things start ramping back up, it can wake up those 40 hosts and move VMs back over to it. And it can do all of this while the system's online. While these VMs are running, while users are in there, the users don't even notice it happening. It's all vMotion, all done by the cluster on the back end. It's really pretty impressive. So you can save quite a bit of just electric bill on this one by turning it on and getting it configured properly. So we get performance balancing and we get power savings with DRS. Really cool stuff, right? And it's fairly easy to implement it too. It's not actually that big of a deal. There are a few requirements that we have. If you want to use that power feature, the power feature is not on by default. We have to turn it on. And your systems have to support wake on LAN. Because when it puts them to sleep, how's it going to wake them up again, right? It's not like vCenter can't push the power button for us, right? It doesn't have that robotic arm attachment yet. So it's got to be able to send a network message to wake the servers up, and it needs wake on LAN for that. So you have to have network adapters to support wake on LAN, and it has to be turned on, right? Which some of them it's on by default, some you have to go into BIOS to do it. It just depends on your environment, right? And then the other thing is we have to pay for the license, right? Because it's not in the standard edition of vSphere. We have to pay for DRS. But assuming that we've got those, we can get in there and turn it on. And DRS is like an upgrade to HA. So you have vSphere HA that's providing you the ability to do vMotion. It's providing you the ability to cluster and have everything highly available. And then DRS kicks in and balances things out, right? Then you turn it on. And once you turn it on, it's ready to go. It's ready to do its job. And you set a schedule for how often you want it to happen. It doesn't run continuously, because otherwise your VMs would constantly be moving around. So you set a schedule. Do I want it to run once an hour? Do I want it to run once every 6 hours? If I'm worried about just power savings, let's say that's the only thing I care about. I just care about power savings. Well, then I might want DRS to run every day at 6 p.m. and every day at 8 a.m. or 9 a.m., right? And that way, at 6 p.m., everybody's gone home, and so it runs and it scales down my environment. And then at 9 a.m., everybody's back in the office, so it runs and it scales up my environment. And so now it just runs twice a day, and that's it. Or I might want it to run every 15 minutes. And so every 15 minutes is balancing the environment and kind of tuning things. So it's up to me to choose how I want to do that. But if you run it too frequently, it does end up with a lot of movement, a lot of moving parts that go on there. So we do have to be careful with that. All right, so let's say that we want to get DRS up and going. It's really just a check mark. It's one of the easier things to configure. I've got a cluster here, and this is the cluster that we configured HA on in an earlier episode. So we've got host 01 and host 02, they're clustered together in the IT Pro TV lab. And if I go into management and settings, you'll see where I've got vSphere HA is turned on, right? So I'm running HA, which is important. I need that running. And then, well, I shouldn't say it that way. We don't need it. You can actually run DRS without HA. It's pretty rare, but you certainly can. Then I'm going to go to DRS, and you'll see that DRS is turned off. Okay, so I'm going to turn it on. And when we turn it on, well, you've got two buttons here, Edit and Schedule. Schedule is what actually turns it on. We're going to schedule DRS. You tell it how often you want it to run. The default is that everything's going to be fully automated, so it's just going to evaluate the environment and make decisions for us. But you can do partially or manual if you want. If you go manual, then what's going to happen is you tell it when to fire up, and you tell it some rules of what you want to move where. You define it. You can really get involved in that. If I expand it, you see a little bit of that information that we can start to tweak, like how aggressive we want to be with our balancing, moving things around, whether we want to enable individual virtual machine automation or if we want it to be manual there too. You can start to customize some of those options, right? But the real glory of it is to go fully automated. Let it deal with it. It'll evaluate the environment and make the decisions. And then we've got our power management. Remember how I mentioned that was off by default? We can turn that on and tell it to do power management. It can go manual or automatic. Again, manual is you trigger it, which somewhat defeats the purpose. And then there's automatic where it just happens on its own. But if you want to make sure it only happens at the end of the day, then you go manual on it and you'll have that functionality. So I'm going to leave my power management off because I don't want my machines going to sleep in the lab here. But we can set that option there. Then we've got scheduling options, and this is pretty important because here's where we actually tell it when to run. Okay, the default is no scheduler is configured. That means we've got to manually trigger it. But I can edit this. I can hit that little change button, and now I can tell it when to run. I can tell it run right now. That's how we manually trigger it. Or I can say, run it right after startup. Whenever vCenter reboots, run it. Or I can tell it to run at a particular time or recurring. And if I want to go recurring, I can tell it I want it to run every hour and a certain amount of minutes after the hour or whatever. And now I can trigger it to run, and it's going to run routinely. Okay, so that's going to make it do its job. I might want to say, some kind of daily interval or whatever. We can come through and specify when we want that to happen. Okay. So maybe I'll set mine to run every 6 hours. So every 6 hours, it's going to reach out there and try and balance my environment. All right. Then you can tell it to send an email whenever it's done. That's always nice if you're like, did it actually work? Did it happen? It can kick us an email off to let us know what happened. All right. I'm going to say OK to that. And now that that's done, I've got a schedule defined. Now I can just hit Edit over here. And I can hit the important check mark. Turn on vSphere DRS. All right, and you'll actually see I've got some of the same options that I had when I clicked that schedule button in here, but in this screen I can do HA as well. So if I'm going to set that up, I can configure both and get them in place. All right, but I pretty much got everything the way that I want it, so I don't need to do anything else. I'll hit OK, and now DRS is turned on. Okay, it's on, it's running, and now we should be balancing, right? Well, when it runs, if I were to trigger it, if I were to go and fire that up, it's going to run. Now, if I go to schedule DRS, and I go to my scheduling options, and I change this, and I tell it to run right now, I can tell it to run, and it's going to evaluate my environment. And it's going to look at how I'm eating up processor and memory, and look at what's available on the different hosts, and evaluate that, and then make sure that it moves things around. Now, I got a failure because I already have an automated schedule in place. So I'm trying to run manually while I have an automated schedule, so it's upset with me. So I'll just ignore that. But I could go and turn off the automated schedule and then run it manually if I wanted. But now it's set up to go. If I go under my scheduled tasks, here's where I should have run it. Here's the task that's already set up, right? And so I can take that task and just run it instead of trying to create a new schedule. and see how I can define more than one schedule, right? So if I wanted to run, remember how I said like run every 15 minutes? I didn't have a minutes option in there, right? But I could create one schedule that ran every hour, one that ran 15 minutes after every hour, one that ran 30 minutes after every hour, and one that ran 45 minutes after every hour. And so that's how we could create that 15 minutes. You can get a little more specific. But right now it's set to run every 6 hours, and it's running in the background. Now when it runs, what does it do? Well, it moves stuff around. In my environment, it's a lab, right? So really nothing's going on here. There's not much to move. Everything's pretty idle. But in your environment, it may see that one node is generating a lot of CPU utilization. One node is generating a lot of memory, and it'll start to balance based on that. And it runs, and it does a great job. Now, there are advanced tools that can go even further. That can look at disk I/O and network. But by default, this is really just looking at CPU and memory and balancing things based on that, right? And for the most part, it does a good job with it. Now, it seems like DRS is pretty easy to configure, and what we've done so far is pretty easy. But we can influence DRS. If I don't care, if I just want to turn it over to DRS, let it deal with it, and I don't want to mess with it, then we're done. We wrap this episode up, and that's it. But you may want to get involved and define what's called affinity. Affinity is where we start influencing the decisions that DRS makes. This is where we tell it, like, you know, it's okay to balance things, but I'd really like it if my SQL server were over here. Or I might have two virtual machines that work together, and so when we move them around, I want to keep them together. Because if one virtual machine is on this hardware and another virtual machine is on this other hardware, now they've got to talk across the network. Versus if they were on the same host, they could talk right through vSphere's bus, which is a lot faster. So I want to keep them together. It doesn't know that by default. We've got to influence it. And I know I'm running low on time for this episode. So Wes, why don't we do a part 2 on this one? Because I really want to show everybody how to be able to manually interfere with DRS and get in and kind of teach it our wishes.
All right, so that sounds good. Do you want to say any parting words? You want to go ahead and just put that in part 2?
Let's wrap it up there, because I know I definitely, if I start talking about it now, I'm going to go on too long. So there is more to DRS, but if you wanted it to be automatic, that's it. It's as easy as checking a little box and setting a schedule and turning it loose, and it does its job. Remember that DRS does play nice with HA. Right, so we didn't have to disable HA. They do play nice together. It plays nice with FT if you have fault tolerance turned on. The one to remember is what I mentioned earlier in the episode, that fault tolerance and VMCP, those two don't play nice together. You can turn them both on. Fault tolerance will automatically disable VMCP. Remember that, it's a great exam question.
All right, Don. Well, thank you for being in the studios with us, and thank you to you, the viewer, for watching. Come back and see us in part 2. Until then, signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.